Let's learn about velocity and acceleration. To begin with, what is velocity? Velocity is the rate of change in an object's position, such as how this ball changes position. The quantity of change is the velocity. Velocity has a magnitude and a direction, which means that it can go south, north, east, or west. Its standard unit is meters per second, and it's obtained by this formula. But what is this formula? V stands for velocity, delta x for change in distance, and delta t for change in time. Here's a fun fact. Negative velocity exists, such as this ball that goes in negative direction, it has a negative velocity. For example, here, Johnny goes 40 meters in 4 seconds to his workplace, and he stays there for 2 seconds, and then goes back down to his house, which means it went a negative direction. Another topic we'll learn about today is acceleration. First, acceleration is a measurement of change in an object's velocity. It also means a change of velocity. It's a standard unit, it's meters per second squared. Acceleration is obtained by this formula, which is average acceleration equals delta v divided by delta t. In other words, change in velocity divided by change in time. Acceleration has magnitude and direction, meaning that it is a vector. For example, right here we have a car that is going at a velocity of 20 meters per second, and then it changes its velocity to 50 meters per second in the course of 5 seconds. Therefore, acceleration equals 50 meters per second minus 20 meters per second divided by 5 seconds, which is 30 meters per second divided by 5 seconds, and then the answer is 6 meters per second squared. Now, let's jump into the next topic, which is gravitational acceleration. Gravitational acceleration is the intensity of a gravitational field. It also plays a big role on the force caused by gravity. Adding on, it is a specific acceleration that all objects fall at, which is 9.8 meters per second squared. It also plays a big role on what is space, physical objects, and time. For example, a free-falling object like this ball gains a downward speed of 9.8 meters per second squared. Next is wind resistance. Gravitational acceleration is a type of friction which is the opposing force towards a moving object against air. As an object accelerates, its velocity and wind resistance increase. For example, for bikers, wind resistance is their worst enemy because it is the friction moving against them. They are fighting against the wind resistance that is slowing them down. So, let's say this guy was falling down and with an acceleration of 6.19 meters per second. Then, we grab the gravitational acceleration, which is 9.8 meters per second, and subtract the acceleration of this little guy. And then this gives us the 6.62 meters per second, which is the wind resistance that was going against him. Here is a very accurate picture of how air resistance and gravity work together. Gravity is part of gravitational acceleration, so we know that it always pulls us down, while air resistance is going against it as a friction. Yes, it might be a lot to take in, but here are some of the formulas we worked with today, so you guys can take notes of them. Thank you for listening.
Created using Powtoon.